go ahead and record that triangle. Look at that. All right. So we found out how to get the area. Go ahead. We're going to dilate this triangle ABCD from the point A. Okay. Remember, we need to dilate from this point right here. Okay. Can we just draw this anywhere? No, we need to dilate from here because right now the shape is really simple, right? It's just a rectangle. But later on, when the shapes get more complicated, like triangles, we have different angles. Okay, we need to dilate from the center point, the point of dilation. That way we can get all the angles correct. Right, when we do measurements. All right, so we're going to dilate this by the factor of what? 2. We're going to dilate by the factor of 2. You guys remember how we did this yesterday? What operation did we use when we dilated? Yeah, we're going to multiply, right? So go ahead, dilate this by a scale factor of 2. All right, come around and watch. And check. Now, make this. Dilate that. So if it's over 1, it's going to get smaller or bigger. It's over 1? Yeah, and the scale factors. It's bigger, right? So it's going to get bigger. How much bigger? 2. So what do you think we need to do? Multiply by? So yeah, we're going to multiply by. Yeah, but we're going to multiply 2 by. Good. And then so you're going to go up here, right? And then you're going to go this way. Right? You can either draw or you can use right? Either way, you do whatever you guys want. So what's the shape? Yeah, so how long? So we calculate 5 and get it. So it'll be right here, right? And then how about this one? We can't just go this way, we gotta go up too, right? You see it? Oh! You got it? Excellent. It's bigger. 2 times, right? So 2 times. 2 times, you guys. Alright. I think we got it. Alright, looks like we got it. So, let's go ahead. We have Paris. Is that okay? Paris. Alright. So we're going to multiply something by 2. Right? So we're going to multiply. So we're going to multiply this length right here. So this is 5. Okay, so we can do 2 times 5. Right? So 2 times 5. I'm going to go ahead and draw this out. Is that okay? 1, 2, 3, 4, 5. So the new one's going to be right here somewhere. All right. So this is 5. That's 5. So that's 10. 2 times 5 is 10. All right. So this is the new length, right? And then what is the new width? 4. So how do you get that? 2 times 2, which is 4. So 4 times 10 equals 40. All right, let's go ahead and test this out. Okay. So we got 2 right here, 2, 4. So this would be our new shape. Okay, so this would be 2 times bigger. All right, that looks about right. So let's go ahead and color this. All right, if you were to count all those squares that we did earlier, you think there'd be 40 of them in there? What do you guys think? No? But go ahead and count it. So we can just look 1, 2, 3, 4. There's 4 rows of 10, which is 40, right? Right. Go ahead. Now go ahead and do this one. We're going to dilate from point A by a scale factor of 3. So this is our first method, right? We can actually count and kind of did what we did yesterday, right? By the scale factor. Go ahead and draw this. This is kind of what we did yesterday, right? By the scale factor. So we came out from our vertices. And color. There you go. This is what we did yesterday. Right, that looks about right. And then we kind of measured and counted out. So that's method 1. Go ahead and do that one.
Yeah, you can use Desmos. Yeah, I encourage you to use those. If you don't have a calculator, use Desmos. Okay?
Desmos will be easier because then you can just change the numbers. Keep the equation, change the numbers. I got you, Brian. Alright. Eileen's got this going on. She's multiplying the scale factor by the length. What's the area? Alright. Perfect. Plug in the calculator. What do we get? Okay. Alright. I see the equations. I see the drawings. Good job, you guys. Alright. Eileen's gonna plug it in for me and she's gonna tell me what she got. What's that?
Factor 3.
Yeah, the factor, scale factor of 3.
Do we do it by 5 or 10? 3 times 5 or 3 times 2?
Well, we're still, good question, my bad. We are still doing this right here, okay? We're doing the scale factor of the original, okay? Sorry. Okay, what do we get? Yes. So this is what Eileen got. She got 90 because she's absolutely correct. Okay. What she did was, can I see your paper? Awesome. She did 3 times 5, and then she did times 3 times 2, and she punched it in the calculator, got 90. Alright, so that's what you guys got. Is that what you got?
No.
What'd you get? 3 times 5 is 15. 15 times 6 should be 90. Is that right? Cool. Alright. Let's go ahead and move on. So, we already did some of this, right? This is the table. We're just going to do this section right here, okay? So do not go past this section. Okay, we're going to calculate the area of the image in square units, okay? This is the scale factor. This is our K. Alright, so if K is 0.5, what do you guys think? Is it going to get bigger or smaller? Is our object going to get bigger or smaller? Smaller, right? Because it's less than 1. Good job. Plus 2 plus 2. Alright, go ahead and calculate the scale factor of 0.5. Do the same thing what we did on the other side. Did we do this one already? We did. Did we do this one already? Did we do this one already? One still yes. Alright, go ahead. You guys can fill these up. All you have to do is calculate 3 of them. Alright? So the answers for the other 3 are on your other side of the page. Go ahead and fill those out and calculate the scale factor of 0.5, scale factor of 2.5, and 4. guys. Winners. Okay. Alright. Give you guys about 1 more minute, okay? 1 more minute. I'm gonna set the timer. I lost my phone. Oh, yeah, we're not recording. Dang it. Alright. Forgot. Well, you should record it. Alright, so I'm just gonna set the timer for about 1 minute. Okay? You should be done in about a minute, okay? With all of them.
They actually gave me.
We're gonna get started in just a second. Alright guys. Where do we get? Help me out. So we got this as 10, right? Then we got from the other side, this one was 40, this was 90. So 0.25, what's the area? What's that? No, this one right here. 2.5. How did you get that, just in case? What did I do? What did I do? I don't know what I did. Can you explain me? Can you explain it? So 0.5 times. So we're gonna multiply our scale factor times our width, right, or length, which was 5. So this is our new length. And then our new width was 0.5, like you said, times 2. This is our new width. Length times width equals area, which you said equals 2.5. And then, who got this one? What was this one? What was it? 62.5. Right. I need somebody else other than Arius. What is that for? Calculate that last one. What is that? The scale factor of 4. What is that? Okay. What'd you get for the last one? Maya, did you get the last one? Yeah. Scale factor of 5. Alright, still waiting. Alexis, go ahead and turn around. And then you just got here, okay? What is it? Perfect. So it should be 160. Okay. Good job. All right. So you guys got the last one? Is that what you got, Eris?
Yeah.
Maya, is that what you got also? You still calculating the last one? Okay. So now, after we get our numbers, it says factor by which the area changed. So how did it change? Okay. How do you find the difference of something? Okay. Not the difference. How did this? How did the factor change from the original? So how do we find that out? What is the ratio, in other words? Right. So what can we do? How do you find the ratio of something? What operation? Divide, right? So we're going to take the new, because this is math, all right? We're going to take the new. What was the area of the old? What was the of the original? This was 2. 10, right? Area is 10. So we're going to take the new, divide that by, take the old, divide that by, take the new, divide by the old. What do we get? 2.5 divided by 10 equals 2.5 divided by 10. You just, yeah, we just move the decimal, right? When you divide by 10, we move the decimal. How about 10 over 10? You guys know that one. And then 40 over 10. Okay. We can just cancel that out. What's 4 over 1? 4. And then 62.5 over 10. Remember, when we divide by 10, we just move the decimal one spot to the left. Right? So we move this to the left. And then Ellen, what is 90 divided by 10?
What?
90 divided by 10. Remember, we can move this decimal right here over 1. What do we get? Yeah. 9, right? And then the last one will be 16. Okay. All right, guys. Right.
I can listen to it later.
All right. So, guys, make sure your attention is up here. Thank you. So, write an expression for the area of a rectangle with L and W. Okay. So, what is the equation for the area of a rectangle? Yep. So, area equals length times width. Okay. Now, number 6. Okay. Imagine that dilating the rectangle with the length L and width W by a factor of K. We're going to multiply by a factor of K. Write an expression to represent the new length. So what would the new length be? What did you guys just do? Not divide. Okay. We just divide up here. But we're talking about something different now. We're talking about the new length. After we made it bigger, what did we multiply that by? What was this group? This is our K, right? Our scale factor is our K. So what would this new length be? Take a minute. If you guys don't know, all right, turn to top. Okay, what do you guys think this new length would be? What would we need to multiply together? All right. What did you guys do to get the new side length? By what? Yeah, which is the letter K. So, beautiful, all right? We got K times, what was their length? So, it should be K, L. This is the new length, right? This is new length, or the dilated length. I'm just going to write dilated. So what is the new dilated width? How can we represent that? Boom, KW. KW, right? So this is the dilated length. Gentlemen, okay, I'm gonna take a point right now, okay? I should be up here, what should be off? Alright. So write an expression for the new dilated rectangle. How can we write that? Right? What's the area for a rectangle? Length times width, right? So what is the length for a dilated?
AL times
L times KW. Is there another way we can write that where we multiply together? Can we combine anything? Yeah, K, right? How can you write K times K? K squared, and then the L and W stays the same, right? Cool. So this is the equation for a dilated rectangle, okay? I'm gonna give you guys about 10 more seconds. I know a couple pencils are still moving. Awesome. All right. So I rewrote number 5 and 7 up here for you, so you guys don't have to flip back and forth. Okay, 5 and 7. All right. I want you guys to compare your answers from 5 and 7. What are similarities and differences between the two? So what's the similarities and differences between the equation in 5 and 7? Remember, this is the original area. This equation right here is for the dilated area. What is the difference? What are the similarities? Go ahead. Turn and talk to your partner. What do you guys see that's different between those two equations? What do you think, Brad? What's different? Different equation? But what's the same? What's the same? What's different about them? What letters are the same? A, okay.
Is that W?
W.
What's that?
L. 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 Okay, what's different?
K.
Okay. Alright, so you guys see the difference? What's the same? K squared? And what's the same? Alright, awesome, beautiful, beautiful. So, you guys notice that the L and the W are the same, right? L times W. What does L times W represent? What does length times width represent?
The area.
Area, right? So, we can write this equation as A dilated, right, equals K squared times the area of the original. Can we do that? So the similarities is that the L and W are the same. And then you guys notice that the difference was which one? Eileen, what was different between these two? What letter was different? Yeah, K, not just K, but K. K squared was different, right? So the difference was K squared. Okay. So looking at this, you guys, gentlemen, looking at this, I want you guys to draw a conclusion about what happens to the area of a rectangle when it's dilated by a scale factor of K. So looking at what we have here, write a conclusion. Write a conclusion of what you guys think happens. Okay? Two, man. I gotta make sure you're okay.
I'm okay.
We have A. What's the difference? Just a K. Yeah, K squared. What can we say about the area of a dilated rectangle? Okay. Yes, draw a conclusion. On the difference, right? Alright, guys. Let's go ahead. Yeah, Justin. Your turn. Who needs to go to the bathroom, Jack? I will. No. Yeah. What's up? She's not back, I'll send you, okay? Alright. Justin, I'll send you after her. Okay. Alright, let's go ahead and do a breakdown. Okay, draw a conclusion. What conclusion can we come up with? Okay, so this is the original area. What did we multiply the original area with? To get the area of the new dilated rectangle. What did we multiply with? K squared, right? So we can say that, what can we say? The area, hey guys, stay with me. Alright, gentlemen, take a point right now, okay? Please. Alright, the area of a dilated okay? Okay. Just want to step aside? Bye-bye. Okay. Okay, the area of a dilated image is equal to the area of the original, times what? You said it, yeah, 5. Yeah, K squared. Multiply by K squared, or the scale factor squared. So the area of a dilated image is equal to the area of the original multiplied by K squared, which is the scale factor squared. The area of a dilated image is equal to the area of the original, right there, the original, multiplied by K squared. Okay. So if we know the area, right, of the original, and we know the scale factor, can we find out the area of the new? Yeah, we can, right? So that's what we're going to be doing. Cool. Nope, not yet. You ready? Good. Alright, so we're gonna do a quick think, pair, share real quick, okay? So I'll give you guys about a minute to think, and you're gonna pair up with a partner, and you're gonna share out loud. So here's what we're doing, okay? So we're gonna compare and contrast 3 methods used to find the area of dilation. So what was the first method? You guys remember? Yeah, we drew, we dilated the image. That's what we did yesterday, right? We drew, and we did a little bit of that today. The other method is what you guys did in the table just now, right? We did the area, we multiplied the scale factor times the length, right? So this was the new length, and this is the new width. Multiply the scale factor times the width, multiply all that together. That's what you guys did in the table. And then this is what we're doing now. This is new. K-squared times the area of the original. Okay? So think about what are some of the limitations of maybe 1 or 2 of these methods, and which method you would like to choose and why. Okay? So take about a minute to think about what are some of the limitations. And then choose a method that you want to do and why. Okay? So you're going to use this method in just a minute. You guys about 10 more seconds to think, and then you guys are going to share. All right. Go ahead and share it. You guys share what method you guys use. You guys want? What are some limitations? Alright, what method do you guys want to use? 1, 2, or 3?
One.
Okay. Do you think there's any kind of limitations to that? No. Think about it. What if it's like 1,000 square feet, 2 meters off, something like that? It'd be pretty accurate. That'd be hard, right? What if it's something a little real tiny? That will have to make it difficult. Yeah. But yeah, you can use those. And what if your measuring instrument was wrong?
Like measuring device was not accurate.
Yeah.
So, all right, guys. Harris, what method do you want to use? Which one do you think it would be easiest for you? That one. 1, 2, or 3? Which one? Pick a number. 2? You think 2 would be easy? Because you just did that, right? It would be easy. How about, Alan said 1 would be easy. But, what's that? No? But it's okay. But is there any limitations you think to 1? Is if we drew? Yeah. If it's really big. And then what Alan and I were talking about, what if like you didn't measure it correctly, you weren't that accurate? Okay. So accuracy, or if it's really tiny? Okay. So good job on that one, guys. Alright, here's a question. Alright. So for method number 1, or method number 2, right? On circles, we can't use that, right? Because circles don't have lengths or widths. Oh, just okay. Because circles are fun. Okay? This is geometry. Okay? We're going to talk about all the shapes. But we can't use method number 2 for circles because they don't have a length or width. But do you think we can use method 3?
Yeah.
Which was area equals k squared, area of the dilated, the D area, k squared times A. So what do you guys think? You said it could work?
Yeah.
Anybody else? Brian, do you think it could work? On a circle or on a pyramid? Yeah? Alright, let's go. We're gonna put it to the test. Alright. Put it to the test. Alright, on the last page. Go ahead and turn to page 4. We're on page 4. So the area of circle. This is the equation for the area of circle, right? You guys did this in 7th grade with Miss Gish, I believe. Some of you guys. With Miss Gish. She was the 7th grade teacher. Some of you guys remember her. But area equals pi r squared. Go ahead and read the question for me.
The area of the circle radius 1 is pi squared. Dilate the radius of the scale factor of A, you have the area of dilation.
Alright, so the area of radius 1, so if we have A equals pi, 1 squared equals 1, right? So the area equals pi, right? So radius 1. So dilate the radius to scale factor of k. Go ahead and do that, okay? Instead of 1, we're going to put k in there. So what would the new radius be? What would the new area be of the circle? Instead of 1 would be k. So what would it be?
Okay.
K, right? So A equals pi what? K. K what? K. K squared, right? You said K squared. So take a look at this. Pi. It's a square pi. Alright. So is the area of the dilated circle equal to the square of the scale factor? So what is our scale factor? Our scale factor was k. And is it equal to the square? Is k being squared right now? And are we multiplying by pi, which was the original, right? So is this true? Yeah. Right. So would this work for a circle? It would, right? So go ahead, we're going to stamp it. How does the dilation you learned in 8th grade connect to what we learned about the area today? Okay, go ahead and finish the sentence. What can we do to a figure? Yeah, we can dilate. Go ahead. We dilate the figure by what? By k. And then what happens to the area of the dilated figure? What is the equation? Yeah, like k squared. And what do we do with it? K squared multiplied by what? The area of what? Area of the original, right? Area of the original image. So when we dilate a figure by k, or the scale factor, right? The area of the dilated K2 area, original, multiplied by the area of the scale factor. We good? So when we dilate, we multiply by the square of the scale factor, multiply that to the original area. Okay. Alright, you're good. Okay. You guys want to go over this one last thing? Alright. Okay. Alright. You already did that, but I'm going to hand out your master check. Here is your master check.